this year. All right. Very last thing on Friday. Didn't we do this problem? Where it said, don't just check if it's continuous. It was like, make it continuous. What has to be true for a function to be continuous? Forever card number 4. That's just a description. I need a definition. F of c must be defined or must exist. What else? Limit as x approaches c of must exist. So the point must exist, the limit must exist, and condition number 3, they must agree. Good. The limit has to exist, the point has to exist, and they have to be in agreement. They have to be on the same page. Okay? So what was I doing here to make it continuous? I said, first of all, what is the c value? Why did I make it -1? Anybody know? What's the name I give the in-between separator? Good. -1 is the separator. And why did I choose -1 as the separator? Does this parabola have any issues in and of himself about domain? No. How about this parabola? Okay, so they're fine on their own. What could be the issue is when they... Well, they're not going to intersect because one, remember, is the left branch and one is the right branch. What could be a problem as we come in on each of them? What if they approach different values instead of the same, right? So to be continuous, what needs to happen as you come from below and above? They have to be the same. They have to be. And the above, well, is also the at. So if we have the at and the above and the below all in agreement, it's continuous. So I chose the below branch. I chose the above branch. And I made the two equal to each other. They actually ended up being the same thing as this guy up here, and I don't even know what was going on. I think my smartboard freaks out right there, right? So I made the below branch equal to the above branch, and the or equal to, the point had to all be the same. So how did I get a equals 2? Subtract the 1, and I was done. So what's different with this guy? So section 1.4. Section 1.4, AP practice. What's different about this guy? How many pieces does he have? Ooh, how many separators does he have? 2. Why just 2? 2 and? So if you were thinking about your number line, the number line's gotten broken into 3 pieces by 2 numbers, right? So I have a branch over here, and a branch right here, and a branch right there. And they're all somehow coming together, but what are you supposed to be doing in this problem? Making them all match. Now hold on. Making them all match. Is K the only guy who's missing? Ooh, so this one's even more exciting. It's not just finding K. What do you have to find? Let's use 4. Find a value for both m and k such that the entire function is continuous. Not x, because x is always changing. But m and k, they're my missing constants. And somehow we need to make them all match. Ready, set, groups, you only have a few minutes to see what you can come up with as far as how to solve. Ready, set, and go. 3 pieces must all come together in order for it to be continuous. 3 pieces must all come together to be continuous. All right, John and Gavin, you're collaborating with Jack and with Joe. Three branches must all come together to be continuous. Who is M and who is K? Group number 1, group number 4, make sure you check in with each other. You show me something. I don't just want numbers. You gotta show me why. But the answer are numbers, right? M equals K equals. Done. Do you show me why? No, show me why. Why'd you do that? How does it meet the definition? I haven't done any work yet. I'm just showing you why I'm going to go the direction I'm going to go. They're parabolas and lines and cubic functions. Their domain is perfect unless the branches don't meet. What kind of math are we going to be doing to make them meet? Limits or plugging in? Does f of -1 exist? Has anybody figured that out yet? If it does, you should be able to tell me what it is. What's f of -1? That's not what it equals, though. Because it'd be -2 minus 1 plus 7, right? Yeah. -3 plus 7 is 4. I agree.
-2 minus 1 plus 7. Oh, wait,
yeah, you got it. Does the limit as x approaches -1 exist? Ooh, we got to make it exist? Okay. For a limit to exist, what do we have to do? Make sure both sides agree, right? So if I'm trying to come towards -1 from below, what piece am I plugging into? Colby, how were you able to find that so fast? What's your brain thinking if you're like, oh yeah, I know which piece? Good, the less than, the greater than. If you're coming from below, it needs to be less than or equal to. So this is the one that's less than or equal to -1. So that's why he plugged into that piece. Oh wait, we haven't even plugged in yet, but that's the next step. It's a limit problem, so plug in -1. So -2 minus 1 plus 7. Oh, that's the same piece you would have plugged into for this one, right? Less than or equal to. But the problem is you can't just come from below. What else do you have to do? Come from above. So the limit as x approaches -1 from above. What piece? M times x plus 1 plus k. What happens when you plug in that one? Zero times m plus k just equals k, right? -1 plus 1 is 0. 0 times m is 0. 0 plus k is k. So in order for this limit to exist, we need these two to agree. So therefore, what must happen? Could say something to the effect of for the limit to exist. But the problem is, does that solve the entire problem? No, because what do we still have to do? Find m. So, let's do m. Does f of 2 exist? What is it? How do you know what 2 is if you don't even know what m is? Yeah, it's to be determined. I totally agree, because don't you have to plug it into there? So 2 plus 1 is 3. 3m plus k, but we already figured out what k was, right? So we plug in k is 4, but no, we don't know what that is. Okay, does the limit exist? Well, it needs to exist, so how do we make it exist? But what are we doing when we plug in 2 to one piece or to another piece? What are we doing? Coming from below? Well, I was following, I mean, we do have to come from above, but we also have to come from below. I'm going in the same order that I did here just for sake of having a pattern. So which piece would be the below? The middle piece. Oh, which we already figured out. We can go ahead and make k 4, right? So then, oh, we already did this work, right? Because the ats and the below are the exact same plugging in. So not just below, but also above. And if we need to come from above, what piece is that? The top, the x squared plus 5, which would be the same thing as 4 plus 5 is 9. That's why you guys are all telling me 9. But the problem is 9. What do we have to do with the limits? Yeah. So therefore, 3m plus 4 must equal 9. Which leads us to m has to equal 5 over 3. So my original question, what is f of 2, is now going to be what? 5 plus 4. All right. It does end up being 9. And we end up with, what is m and what is k, such that these functions are continuous at the separators. He was fine, he's a parabola. He was fine, he's a line. He was fine, he was cubic. But where they met up was not fine until we made it fine by choosing m and choosing k. Why was he harder than the one that we did on Friday? More variables, yeah, number 1. And number 2, it was also 3 pieces instead of 2. Does that make sense? But do you see how you have to basically, the shortcut is plug into each piece on either side and just make them match? Or I should say make them equal. But on this one, we had to plug into these two, and then these two, and then make them all, make the first two, second two all, I keep on saying all. They don't all need to equal. We need the first two to equal and the second two to equal. All right. Questions before we leave this page? Where'd you get lost? Where'd you get stuck? Definition of continuous. The point has to exist, the limit has to exist, and they all need to agree. In order for a limit to exist, we need to come from both sides. Good, 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 good. All right, let's get back to the notes you guys are taking at the very beginning of class and figure out what on earth is this deal about a closed interval? What on earth is going on with intermediate value theorem, and how does that apply? Kiddos, check out the calendar online on the website at some point. I need to update your Google Classroom. I ended up shifting everything a day. So that's why Google Classroom I don't think is totally up to date right as far as like the future assignments, because I ended up, homework number 5 was going to be due tomorrow, but on the backboard, homework number 5 is not due until Thursday. There are 6 sections in chapter 1, so homework 6 will be due after the Spirit Day weekend, which is Monday. We're going to start reviewing Monday, finish reviewing Tuesday, test on Wednesday. And this test, the chapter 1 limits test, is, out of the entire year, I do believe, the test that students most commonly underestimate more than they should. That you're like, psh, got this, and then you go into it and you're like, actually, even after you take it, almost everyone will turn it in early. In the sense of like you try all the problems and you do it and you turn it and you're like, got that. And then when you get the scores back, you're like, because there are a lot of common mistakes and the multiple choice answers. If you've ever taken any sort of STEM AP class, the multiple choice answers, some of them look real good and yet they're real bad. So you're going to be like, I got it, circle, and then you made the common mistake. So you got to make sure that you have full understanding of these limits, and the more we practice, the better. So let's get through this. You guys can have homework number 5 totally done. Homework number 4 totally finished up tonight. And then we can go ahead and bust out the rest of the sections tomorrow and Thursday. Continuity on a closed interval. Okay. I want you guys really quickly, you have this graph already in your notes, and then you have these 3 intervals. They're not points, they're intervals, left to right, left to right, left to right. These 3 intervals, I want you to look at them, and I want you to ask yourself the question about the graph right above it. Would I, right now, just looking at the graph, that's it, would I say that the function is continuous? First interval, yes or no. On the second interval, yes or no. And on the third interval, yes or no. You don't even have to write it. Just what would you think? Looking at the graph, yes or no on the first, yes or no on the second, yes or no on the third. Without even talking about what all this blah, blah, blah is. What would you think as far as whether or not the function is continuous on the first, and or the second, and or the third? Give a thumbs up over the options. How many of you guys think it's continuous on the first one? Have you guys, give me a thumbs up if you think it's continuous on the second one. Give me a thumbs up if you think it's continuous on the third one. Oh, I was saying the thumbs up. Want to do it one more time? Who thinks this is continuous? The function is continuous here. Thumbs up. Okay. Keep the thumbs up if you think it's still continuous here. Or put the thumbs up. Keep the thumbs up if you think it's here. Okay. A lot of us are very wrong. So here we go. You ready? I didn't say whether it was the thumbs up or the people that didn't put thumbs up. On which of the following is the function continuous? Guess what? That's a yes, and that's a no. All right, let's talk about it though. Ready? Whenever you have an open interval, it's actually the easiest because an open interval says totally disregard the ends and only look focus on the in-between. Open intervals say totally disregard the ends and only look in between. So we get to disregard anything and everything that's going on at 2 and disregard, well, what's going on at negative infinity? I don't know. I can't get there. And just look in between. Guys, in this entire in-between branch, are there any breaks or holes or jumps? No. So he's continuous on that interval. No big deal. Only look in between. As soon as we have closed intervals, we have to not only consider the in-between, not only look in between the 2, but we also have to look now. There's a little bit of a typo. We have to look, thinking about the interval, on each side of the endpoints. So first of all, here's 2, here's 5. Are there any problems in between? No. Now we have to think about, okay, I'm coming from 2 to 5. So there are numbers a little bit above 2. No numbers below 2 are included in the interval at all. So only numbers above 2 are included. So as I come from above 2, are there any problems? No. Where the limit is pointed, the point is. Where the limit is approaching, the point is. They're in agreement. The point is where the limit is approaching from above, which is what the interval is talking about. The numbers only in between 2 and 5. That's what this says. if f is continuous as x approaches the left endpoint from above. As I come towards 2 from above, it's fine. Now, question. How can you approach the 5 with these numbers, from below or from above or both? How can you approach 5 with these numbers? From below, from above, or both? Only from below, because 5.1 is not in here. 5.01 is not in here. Same reason 1.9 wasn't in here and 1.99 wasn't in here. So only coming from below. Any problems with where I'm supposedly approaching and where I'm actually going? Where I'm at? Or do they meet? They meet. The approach is the same thing as the at. So from below is good. Now who can find the typo up here? What's the typo? No, that's okay. Good. I can be coming towards A from above and B towards from below. Just change this to a B. When you're looking at an interval, a closed interval A to B, you can come from above A and below B. You can't come from below A because it's not allowed. You can't come from above B because it's not allowed. Good catch. So there's a quick typo, you guys. Okay. So coming from below 5, totally fine. Where I'm approaching is where I'm at. Coming from above 2, where I'm approaching is where I'm at. Why is this one false then? Are there any discontinuities as I go to infinity? No? What's wrong with the 5? You would be coming from, think about these numbers. You'd be coming from above him, right? Because now he's on the left. And as you come from above, where's the approach? Down here. But where's the at? From above, the approach says one thing, the at says something else. I'm not even looking at the below, but I am looking at the at. So the approach says down here, the at says there at 5. It does not work if you're coming from above. From below, it was fine. From above, it's not. Closed intervals, it's kind of like a technicality thing, but it can trip you up for sure, for sure. So yes, yes, no. Yes, yes, no. A little bit tricky? Okay. Keep this page close if anything comes up when you guys are going over questions. Okay? Okay, this guy. Ugh. You guys already wrote him down. Did anybody find where there's a little bit of notation that's missing because my font wasn't letting me do it? Okay, what's missing? X approaches C. Oh, no limit. Yeah, no limit's necessary on this one. Good idea, though. Let me zoom out just a little bit. Yeah, the C and the K. Do you guys see how there's a big old gap? It's an interval. There should be a little E right there and a little E right there. K is an element of and C is an element of. Talked about him a little bit earlier. Is within. Is an element of or is within. I couldn't get that notation in with the font that I was using. So, oh no, and there's a yellow box. What does that mean? Okay. What's going on? If I was to label down here, A and then B. A is always the one on the left, B is always the one on the right. What's f of A and f of B? What does f of always point to? What kind of values? Y values. So what if I was to make f of A up here and f of B down there? Doesn't A, f of A mean there's like an actual point there with that x and that y? And doesn't B, f of B mean that there's an actual point there with that x and that y? A and f of A, B and f of B. It's just an x, y of a point. What condition needs to be true for this theorem to apply? If, it's called the hypothesis of the theorem, if f is continuous. Continuous means, okay, description. It's not the definition, but description. Means you can draw the graph without picking up your pencil, right? If I have no idea what this is. Is it a line? Is it a parabola? Is it a trigonometric sinusoidal oscillating thingamabob? I don't know. But if I somehow connect this point with that point with a continuous function, is there any way to skip over any k in between those two y values? Is there any way to skip over all of those different y's? No. Now, how many times am I going to pass through? Maybe once. This is going to pass through all of them at one point if I were to cut that. But what if I was to do something like this? Didn't I just pass through 1, 2, 3? I passed through these k's multiple times? And I passed through other k's that were like above or were below. I have no idea how to connect those 2 points, but if a function is continuous, I know however I connect those 2 points, it must pass through every, ready? In between function value to get from one to the other. What does intermediate mean? It's not beginning, it's not advanced, it's in between. Value, function value, y value, in between y value. If a function is continuous on a closed interval a to b, and if there's some sort of k, if you want to mark it, you can mark it. Something in between, doesn't matter where you put it. K represents basically all the in-between y values. If there's some specific k that's in between those two, there's going to be at least one c within a to b, such that there will be a point at that c at k. If I need to go from one to the other, for any k in between, there's going to be an in-between c that maps to it. At least one. It could be more than one. It could cross through all sorts of different times. It could cross through all sorts of different times. But at least once. So let me go ahead. Well, yeah, let's go straight to an example. There is like another illustration, application. That's the whole IVT guarantees the existence of. But let's do an example first, because that's what you guys need for your homework. I told you guys to stop whenever you saw intermediate value theorem, which would have been in like the 90s. So let's get this guy on the board. P.S. Forever card number 5, yeah? Forever card number 5. IVT, the intermediate value theorem. P.S. You might want to check out your calendar. I think there's a forever quiz coming on Monday on all the cards up to this point. Okay. 99's pink. That means if you scan the QR code with the CalcChat app, you can watch a video on it. Let's do number 100. You can watch a video on 99. Number 100. Verify that the intermediate value theorem applies on the indicated interval and find C. Could be one value, could be multiple, guaranteed by the theorem. Okay, what has to be true before we can even use the intermediate value theorem at all? If f is continuous. Question, is f continuous?
Yes.
Why? All polynomials, yeah, that works. It's a polynomial, yeah, of course it's continuous. You could say something to the effect of f of c will equal the limit as x approaches c of f of x for all points in that interval if you want to be super snazzy. It's a polynomial. All polynomials are continuous. Since f is continuous, and, wait a minute, what else has to be true? If f is continuous, you guys are reading it, right? If f is continuous on a closed interval a to b, this one is, and if there exists some, what else has to be true? Who's k in this problem? Good. This would be my k. What else has to be true? K has to be between. Isn't there something in the theorem? What's k have to be between? Oh, okay, hold on. Wait a minute, we need to figure out who is f of 0 and who is f of 3. F of 0 is, f of 3 is 9 and 8 is 17 minus 18. Okay, am I good? Is 0 in between f of a and f of b? Okay. Going between 8 and negative 1. Yeah, 0's in between 8 and negative 1. Okay, good. Then there must exist an x equals C have to be in between according to the theorem? Uh-huh. Is it open or closed interval, A and B? Good. And what was A? 0, right? And then B? Such that f of C equals K. Wait a minute. So we know the theorem applies, but what they're asking for is go find C after you've applied the theorem. Go find C. Well, how do we find C? When does f of C equal 0? Who are we setting equal to 0 back here? F of x. Good. So we're going to say f of C. Well, we're setting that equal to 0, which means c squared minus 6 times c plus 8. If you guys want to be super specific, you can just plug the c into the x spot. And all we have to do is solve. And hopefully most of you guys, with just a little bit of effort, or maybe no effort at all, should be able to solve this and say, hey, c equals 2 and 4. Yes or no? No. What have you not thought about? C has to be in between. So the only guaranteed C value is only 2. Dun, 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 dun. All right, cool kids, we made it. Woo! Finish up section 1.4. We'll grade it tomorrow and go over questions tomorrow, but no new pictures submitted on classroom. 1.5 is due Thursday, yeah. I have to go change all the Google Classroom deadlines.